On behalf of VMUG, I'd like to welcome you to today's webcast, Swap, Drop, and Roll, a live look at memory management presented by Rob Girard of Tintri. Thank you for participating in today's webcast and for your continued support in the global VMUG program. Before we begin, I have 3 quick housekeeping items. First, today's webcast will be recorded and available for on-demand. Second, a Q&A session will follow today's presentation. All questions will need to be entered in the Q&A window at the bottom of your screen. Third, there will be a short online evaluation that pops up as you exit the webcast. Please make sure to take a minute and let us know what you thought of today's session and what you might like to see going forward. All right, let's get started. I'd like to introduce you to today's presenter, Rob Girard, Principal Technical Marketing Engineer at Tintri. Rob, I'd like to turn things over to you.
Great, thank you very much, Annie. Can you hear me okay?
Yeah, you sound great.
Okay, hopefully everyone out there can hear me as well. All right, so today's session, Swap, Drop, and Roll, this is a first for me. It was an idea that I had to do a bunch of lab exercises around memory management. So I put together some scenarios and stuff, and I decided to just do it straight up live demos, kind of skip the PowerPoint. Feel free to drop in questions as I go. I'll get to them if I can. If not, I'll find some time at the end too. I've got a lot of stuff to pack in. I'll probably move very quickly. Apologies if it's too quickly, but it's okay because there is an on-demand version. So if you want to catch up later, then feel free to tune back into that. But while you're here live, you can ask and interact live. Okay, so let me just share out my screen here and make sure this works. Okay, Annie, can you just confirm that you can see this?
Yeah, it works.
Okay, perfect. All right, so what I was doing was pushing around a bunch of scenarios, and this is all around memory management. So a little disclaimer, I've done a lot of stuff that's like, hey doc, it hurts when I do this. So don't try this at home on your production stuff, but definitely do try it at home and have a, try some of these things for yourself so that you get a feel for how they work. I'm a really hands-on type of person that learns by doing. So I'm not going to go into a lot of theory on this. I've been working with vSphere for 12.5 years. Got drunk on the VMware Kool-Aid back in 2005, got my VCP, and have been pretty entrenched in it ever since. So along the way, I've learned a few things about memory management, but a lot of the basics have kind of stuck the same. And so, again, Q&A, and at the end, there's going to be a feedback form. So please fill that out. Be honest. That helps me with my content, improve it. If you've got any suggestions, throw that in there. I'd really like to refine what I'm going to show you for a VMworld presentation. But for now, you're getting a first look at some pretty rough lab work. So how about I go over my lab setup first? So I've put together a bunch of VMs here. And for the most part, these VMs are 8 gig of RAM. Either that is real RAM, that's virtual RAM, there's a mix of it, and I'll go into that with a little more detail. I could have used some kind of memory simulator, noise generator, kind of like an IO meter type of stuff that drives me nuts on the storage side. So I thought, why drive myself nuts on the application side if I can find a real application? So I took an application that I'm quite familiar with, which is SQL Server, and decided that I figured that I could probably create some scenarios that I had in mind. And sure enough, I was able to create some, and I want to share those with you. So I hope nobody minds that I'm using the thick client here. I do have a 6.5 set up, and it's current with the web client and stuff. I just kind of, and I like getting things done quickly, I guess. So here are my test VMs that I've spun up. I think I've got 18 or so in here. And so these first ones here are SQL memory reserves. And so these are reserves at 2 gig, 4 gig, 6 gig, and then the full 8 gig. And when I see reserve, what I'm talking about is we go into memory settings here, and we go over to the resources tab, memory, and this is where we can play around with reserves, or one of the places we can play around with reserves. So a reserve says that this VM gets real physical memory from the host that it's on. No substitutions will be allowed, and it will not share that memory out with other VMs. It may share that out through ballooning internally, but this reservation is going to say, hey, this is my stake. So if you have anything that requires very low latency, high performance, reservations are your go-to. To do reservations kind of en masse or for a group of stuff, this is where we can access that in resource pools. I'm just going to go into the hosts and clusters view. And this is where you can set up resource pools. And resource pools allow you to do it. And this is a little bucket that all the VMs inside are going to share this. And I'm not going to go on into the theory on this because there's a lot of material written on it. A lot of it's BCP 101 kind of stuff. But just know that it's there, and just PSA on resource groups. Resource groups are not folders. If you like folders for organizing things, that is what VMs and templates view is for, with all the folders you could possibly want for your environment. That's the place to do it. Moving on, I've got SQL page, and apologies that these kind of blended together. I was trying to stay within 15 characters to have a nice short name for my Windows servers when I ran sysprep, and didn't realize these would bump up against each other. But I have a SQL page 16 gig, SQL page 32 gig, and SQL page 64 gig. Essentially what I'm doing with these guys is I'm saying, hey, I want you to be a certain size. And that size, physically, you can have 8 gig of RAM, but you're going to tell Windows that you are bigger than that. So I want you to page your memory. And the reason I want it to page is because I want to compare the difference of what if I'm paging. So if I have a shortfall on memory, which is a physical resource found in your host, I can fake it several ways, and I can fake it with disk. And there's kind of two main ways that you would fake it with disks, and one is through swap file. So when you create a VM, you get a swap file. I'll cover that in a minute. The other is the guest itself. So the guest itself, remember, Windows or it's Linux, thinks that it has its own physical host, and that physical host is going to page. So the page is where we've run out of memory and we need to store stuff, not persistently, but we're just going to drop it in there short-term, a little sorting bucket of sorts. Same way we'd use our memory, but it's slower. And I wanted to know if we have fast disk under both page and swap, because I am running this on some nice all-flash, and what's the big, what's the difference here? And so I did find some pretty cool differences. Next one I have here is a mix of page. So this one is SQL page 2 gig, mem 6 gig. So for that 8 gig VM, 2 gigs of it is paging, and the VM itself will be set to 6 gig physically. And we move on, and I've just kind of mixed this. So I've got a 4 gig, and a 6 gig, 2 gig. Then we move on, and we've got a swap. So the swap are the ones that I'm intentionally, I want to try making them swap. And so swap is where we don't have the physical memory, and we are going to, the hypervisor is going to give it to us. Now the VM inside is going to think that whether it's coming from physical memory of the host or coming from swap, it's going to think it's all the same logical memory that has been assigned to it. So when we go in Windows and we look and we see that this VM has 16 gigs, Windows believes it. You can see here that memory is set to 16 gigs. Okay, so I've assigned 16 gigs. So where's the swap coming from? I go into this one, edit settings, go back to my resources. This is where we have our limit. So our limit is a ceiling. So this is, do not use any more physical memory than this limit right here. And by default, this will be unlimited and just all you can eat buffet. Have as much as you like. vSphere does an excellent job of sharing resources across a lot of workloads. some low latency workloads, SQL being one of them, may step on each other's toes. Things might kind of get a little bit stale, and you may want to put some reservations to make sure that what you've assigned it there. But one of the benefits of virtualization is the ability to over-provision, over-allocate. And if you're not getting performance issues because of that, then you should be good to go. So what I've done on these ones is originally I set them with a ceiling of 0. I said, take the whole thing at a swap. Turns out that's a really bad idea, and your VMs are going to end up just locking up on you. So again, it's one of those, hey doc, it hurts when I do this. But I found that if I set 1 gig of physical RAM and the rest of that other 15 gigs was swap, it seemed to work just fine and interacted with the stores the way that I wanted it to. So I've got 3 scenarios here for 16 gig, 32 gig, and 64 gig. These swap, these ones and the page ones of this size are the only exception. Otherwise, they're 8 gig VMs. Moving on, this is my base. So this was the one that I set up. And then I cloned this out, did sysprep. I used Tintri cloning tools to do this. This one, you know, this is not going to be a sales pitch call, but I am going to show you most of this through the eyes of our Tintri UI. Why? Because we can do some really cool things that you're not going to find elsewhere. And we'll give you a pretty cool perspective on what's actually happening from an I/O perspective. Moving on here, I've got SQL swap lim. So this is where I've limited the amount of physical memory with a sliding scale. So this one was 0. So I said, hey, allow none. And when I have this one here and it came up to do its preparations, we ended up with this at some point. And so this thing is completely frozen. And interestingly, it does not look very frozen on the back end. On the back end, it's looking very hard. But in all intents and purposes, this thing is locked up, frozen. Power cycles aren't helping anything, which explains the VMs below it, which are SQL swap limit, 0 gigs again, take 2 and take 3. And in all cases, you've failed. So one of the takeaways is setting it to 0 is just a bad idea, even if you want to play around with it. However, this one here, what I did was I let it have the full amount of RAM, do its sysprep, and then I went and knocked it down to 0. And in that case, I could stand Windows up, and I thought everything was good, and then it did exactly what the others did. I may or may not see this, but I'm clicking, dragging, and trying to interact with this thing, and it is completely dead to my touch. It's not going to ping, and this thing is just frozen. Now, if I did increase, if I did back off that limit, which I had done earlier, I was able to breathe life into it and sprung back to life. It may not be an instant thing, but it did spring back to life. So let me just pop it up here, and that'll give us some nice graphic to look at later on. And we'll see if that's responsive in a minute or a few. And then we've got the SQL swap limit 2 gig and a 4 gig and a 6 gig. So all I'm doing in this case is saying where I'm making that limitation line of stop using physical and use swap at that point. And swap is going to go to disk, and in my case, it's going to go to the default location in the home folder of the VM. You could also set swap files in a dedicated folder. You could have localized flash in your server, and some people see this as a nice, potentially cheaper alternative to real memory. So those are the ones that I've set up, and let's take a look at them. So moving through setup here, the tools that I'm using are inside. I'm using HammerTV. So HammerTV is a great little tool that is free to download, open source, and it looks like this. So I have up here some HammerTV clients. These are dedicated clients. You can run HammerTV on, you can run HammerTV on the same server as your SQL server, but I strongly advise against that, because what you're doing is you're using front-end client load to compete with back-end SQL services. So if you're trying to test something end-to-end, all of it matters, including the front-end network between you and your client. So Here I've got clients separate from my SQL servers. And so I've got 9 of these. Currently, 3 of them are hammering against the SQL page of the larger sizes, 16, 32, and 64 gig. Another 3 are hammering against the swap ones at 16, 32, and 64 gigs. Then I've got 3 left over, and I saved a little surprise for you guys. I actually don't know what the results of this is going to be. I do speculate what it's going to look like, but I want to get this kicked off so we can see something happen. So let me jump into HammerTV Client 1. I've already configured the options for SQL. Taking a look at it, this is the SQL server that I'm going to hit, SQL swap lim 2 gigs. I'm going to do a build, and I'm going to choose the number of warehouses I'm going to build. The maximum that HammerTV will allow is 5,000 gigs. Through trial and error, I found that if you want to know how big that is from an MDF, LDF perspective, the MDF is going to be the same number of gigs if you lop a 0 off. So in this case, I'm going to create 80 warehouses, and so that's going to end up being 8 gigs in size, which is the same amount of memory. I've told SQL to use at least 6. Now, SQL wants to put as much of its data in memory as it can and avoid the days of slower disk. So its priority is to hold as much of your databases in memory as it can. So as I create this, what it's going to do is it's going to create a new database on the SQL server and start to populate it. So I'm going to go ahead and hit OK on this. I've already configured the other options for my driver script, the number of virtual users. I'm going to use 8 virtual users. I found that the sweet spot of virtual users is in and around double, when you're building, that is, in and around double the number of cores of your client. However, when you go into HammerTV, there's when you're actually transacting with it versus just populating a database, that's a different beast, and the number of users to find the sweet spot varies, and it takes your entire infrastructure lets you clean account. So let me just click build here, ready to go. I have so here we can see there's 8 virtual users. This one is creating a schema on the database. It's going to do this. This one is going to wait a little bit. Once this schema is created, the tables are created, these ones will start working. So it started working. It's loading stock with a warehouse ID of 1. This virtual user is doing a warehouse ID of 11, 21, 31, 41, etc. The next, and it'll just keep on going through and populate this database. Over on the transaction counter, I've changed this from a default 10-second update to a 2-second update. These numbers can be quite skewed from reality. You'll see these posted as hero numbers quite often, and these are not hero numbers. I've got a 2 vCPU SQL server on the back end of this. I'm definitely not trying to impress anyone with these kinds of numbers here. And the numbers are a little bit synthetic, but they are a good indicator relative to itself of it getting better or worse. And so this is about in line with what I'd seen running my other tests in the 600 to 800,000 transactions per minute range. And these are transactions per minute, not IOs per second, as we typically refer to as storage. So let me just go off and build the scripts on the others, so client 8 and 9. And now these ones correspond to those lim servers down here, 2, 4, and 6. And with any luck, I've started it early enough, and we will hit our memory threshold to see the first bit of the interesting thing in maybe about 20 to 25 minutes. So let me just kick this guy off as well. All right, so now that that's going, let's go take a look at something that is running. So we started to cover our tools. We're using HammerTV. Another tool that I use in the lab all the time is Snagit. So when I was an IT admin, infrastructure architect roles, very hands-on for, hold on, just got a call coming through and a chat up, and I'm just going to double check to make sure that someone says that you have, okay, nope. Making sure it wasn't a call to say that you just dropped the line. Annie, can I get a confirmation you guys can still hear me? Or any attendee, just pop a Q&A.
Yeah, no, you sound great, Rob.
Oh, okay. Fantastic. All right. Okay, moving on. So the other tool that I absolutely love in my lab is Snagit. So it's funny because as an IT admin, I used to get so frustrated with requests for this because I'd look at the cost of it. It's like $150 per seat, and there's upgrade costs, everything else. And I'm like, come on, give me a break. Windows has Snippet built in. And it turns out that I owe every single user that I ever said no to with Snagit a giant apology, because this is one of my favorite tools. I run Windows inside my Mac because I like the Windows version better because it has tagging in a library. So in my role as a tech marketing engineer with Tintri, I've got the honor of getting a lot of time in the lab and and I've got some pretty sweet lab setup. So the kinds of things that I'll do is things that most of you don't have time to do in your day-to-day work. So it's, guys like me that hopefully can help you out and shed light on kind of tedious little exercises and tests that I can get all the results together and prove it. But as I do this, I do these to produce white papers, best practice guides and stuff. And I want to make sure that they're all technically accurate. So when I'm running things like tests, so even the stuff that I was doing, staging all this, I'll have these clips here, and I can go back in time and look at exactly what's going on. So if anyone says, hey, how did you get this? What else was running? I don't think it was isolated. I don't think this or that. I can go back, rewind the tape, and find out for sure. So it's not just to defend myself, it's also to not take such tedious notes. So I've got this thing running all the time. My library is full of thousands of images, videos, tags into all the kinds of things that I jump into on a day-to-day basis as I interact with the field. So this tool is fantastic. So it's also my backup here. So I captured some nice highlights of some of the testing that I was doing, because some of this stuff hard to recreate and hard to recreate on demand. So somebody out there just gave a shout out to an alternative to Snagit, and that is awesome, called Greenshot. Never tried it. Thank you very much. I will check that out. Apparently it's free and works just as well. So I will check that out. Thank you, Glenn. So here is a look at one of the ones. This was the swap one that I wanted to make sure was swapping. And initially, as I said, I'd set it to 0, and I had a little bit of issue. And I brought it back a little bit and set it to just 1 gig of physical only. The VM has 32 gigs of it, which is going to be our granted size up here. This as we boot it up, it popped up to about 32 gigs. A lot of this detail you're not going to see on vSphere graphs once it rolls off, because what we're looking at is only 1 hour of real-time roll-ups. And I don't know how well you guys are familiar with the flaw of averages when you're looking at graphs, but not only is the granularity of the data change a lot. So in real time, we're going to have this massive spike. When we average that out over several data points, it turns into just kind of a big one. Average it out more and more and more, and then it disappears. So the controls in vSphere, if you're not familiar with them, is you can go into your vCenter server settings, and you can look at your statistics. And you've got statistics, so your real time are every 20-second intervals. And then this is set up as a default right now, all stats level 1. Your real time is a stats level 4, which is a maximum. And every time you up your stats level to something higher, it includes more and more metrics. So all the metrics you see in real time, once you get into this 1-day view, you're taking, it takes 3 of them to make up a minute, and then 5 of those to make up 5 minutes. So 15 data points, average those together, and we'll get a 5-minute data point. So when you're looking historically at, a 1-day view, keep in mind that that's been averaged, and you no longer have the ability to add all the cool fields that are there unless you crank up those stats fields. Now, word of warning, if you're going to crank any of those up or change your granularity or anything, it can consume a lot of space and take and be a heavy load on your vCenter. So do that with a lot of caution. But if you are net new in an environment, debugging it or something, highly recommend doing that. So getting back to Snagit, where was it over here? Here's an example where what I did was at this point in time, I said, oh, let's, you know, at first I forgot to set the limit. Oh, let's change this to our ceiling of 0. And when I had an issue, somewhere over in here, I needed to bring it up to 1 gig. And when I did that, what happened was that the memory that it was using, which is this granted here, this memory came down. It slowly destaged itself. There was no pressure from the host to take this back. So we could go ahead and just slowly let it trickle out, and as new memory was needed, it could just overwrite those blocks. So no big rush to get it out. Eventually, it fell out. And then what happened here was 2 different memory mechanisms came in. The first one that came in was ballooning. So ballooning, the ballooning happened when, so the other thing that started here is this is right around the time where I started HammerTV load to start populating a database, which is then populating in memory. Pause for 1 second. Question regarding recording of the webinar. Yes, this is available on demand afterwards. You can just go to the VMUG website. You'll find it with the other on-demand ones, which is my go ahead to just kind of go fast because you can come back and listen to it again if you're interested. So here's where ballooning kicks in. Now, ballooning is where we take memory that is inside of another VM, and as far as vSphere is concerned, that guest is not consuming that memory. So if it's not using it, then use it or lose it applies, because we want to fit more and more VMs into our host because it makes good economical sense. So what it does is it says the hypervisor will talk to VM tools inside. It says, hey, VM tools, can you spot me? I'm a little short. I got somebody else who's running out. Yeah, no problem. So if you're ever looking inside of your servers and you thought that it was a bad idea to run VM tools because, oh, it's a resource pig, it's such a memory hog. Well, if it's a memory hog, that's because it's ballooned. It stole memory to then give it to something else through a back channel in the hypervisor. So that was actually helping other loads, and having VM tools in there is a very, very good thing and highly, highly, highly recommended. Not having it can lead to some ugliness, performance concerns, and an inability to do some other cool things like quiescing the disks inside and that kind of thing. So here is, this is what happens. The ballooning kicks in, and then down here, the swap kicks in. So let's go and move on a little further here and get to my favorite tool, which is the Tintri VMstore. Tintri VMstore, if you're not aware of us, we are a storage appliance designed from the ground up for virtual environments. So this is one of our 2U all-flash units. This is an EC6090. This is one of the biggest and baddest VM stores in our lineup. 2U, completely fully redundant, dual controller, active, standby, NVRAMs all wrapped up. We won't act it unless we have it safely on both sides. This is a picture of the hardware. Again, this is the front of it, a little 2U box. We've got expandable drives, and we can see which controller is active. Cool, okay, it's hardware, it runs stuff, it runs it fast. The cool thing is that we can isolate VM traffic, and we can look at end-to-end latency. And this end-to-end latency and this granularity of knowing the data on here, because we wrote a custom file system, is what is making this tool particularly interesting for looking at memory. And memory and storage are usually not one and the same, but a memory shortage could impact your storage. And you may not know that it's actually a memory shortage that is causing your I/O to go up on your storage. So what I'm looking at in our dashboard, just a quick primer for those of you not familiar with it. There are, IOPS, because every storage guy loves to talk about IOPS. These are like RPMs in a car, though. They really do not tell you all that much other than, hey, look at me, I'm going 3,500 RPM. Is that fast? Yes or no? Depends what gear you have it in. And the gear you have it in would be your block size. And so if you're pushing a lot of data inside of every I/O, you're not going to see this hero number IOPS. However, you will see hero numbers on the throughput side of things. These are 10-second real-time stats at the VMstore level for the entire array. This array has 90, it's effectively 91 terabytes. That's one huge bucket presented to vSphere, and there's no LUNs or volumes. We just throw our VMs in. We ignore all the rules that say don't put more than this or that in there, and we get all the benefits of running something like Vivos, which we do support as well. We get all the benefits of individual LUNs that were per every workload, so we can see every single VDIS. So what I love about this here is that when I'm looking at this IOPS, right, hey, here's some activity, show a split graph with some latency. Now our latency, as point out, is a end-to-end latency that will match what you see when you're doing performance analysis in your VMs. So when your VM asks for something and it says that there's high latency, well, so it comes back and you talk to your storage guy and your storage guy tells you, nope, it's 0.5 milliseconds, no problem here. That's not the whole picture. What you care about is how long until your application gets it. So it needs to issue an IO, goes through a vSCSI adapter internally, which thinks it's block device, travels through the hypervisor, gets out the hypervisor onto a network, whether that is fiber channel or Ethernet or some other type of network, gets over to some kind of storage appliance, that gets processed, hits various stages inside storage, and then gets turned around and sent back. And so what we have here is an end-to-end timing. And so this is for the whole VMstore. But again, this is where the flaw of average comes in, because when we look at this and we see that there's this latency spike, I can mouse over this, I can see that, hey, this is network latency. This is not a storage problem, but the application would think that it's a storage problem. But this is 5.4. This is not everybody getting 5.4. This is very specific VMs that are hitting it. And on the right-hand side, I can see the individual contributors. These are the top 10 contributors at that point in time. So the most two affected VMs in this case are TTVM-SQL1 and TTVM-SQL2. Both of them have high latency, 10-minute averages at 7.8 and 9.7 milliseconds. Hey, bear with me a little longer because there's a reason why I'm going through all this. Fast forward to 6:50 a.m. or, I don't know, 4:10 a.m. Yes, I love you guys. Yes, I pulled an all-nighter to put all this together to have fresh data for you. And here we have some nice data with VMs that are live, and we can see what they're still doing now. And here are the VMs and the IO they contributed. So this particular VM called SQL SWAP, lim0, remember, this is the one where I set a ceiling of 0 gigs and said, I want you to swap all of it. Well, guess what it's doing for me? It's swapping all of it. Now, if I fast forward to right now, lim0 version 2, hey, look, he's on the top. And hey, his buddy, the original, is there too. And I'm surprised I don't see lim3 in here, but that might be because I released the, oh, there he is, a little while ago, but I had released the cap on it and relieved some of the pressure. So this just would normally look like a bunch of IO going in, and you wouldn't know what VM's doing it. Now I can see exactly which VM's doing it, which is very helpful. Now let's go and look at all of our VMs. So this VMstore has 1,070 VMs. This thing is capable of, I believe the stats are 7,500 on this particular model, and these are derived from having needing to reserve a whole bunch of space to store all this data for 7 days. So I can look historically back and see if there's anything interesting like, whoa, what was that spike? Oh, that was this hack load at 35,000 IOPS. Cool, I know who it is. And it also stores all the information for each VM. Now, each VM is its own average. So these are 10-minute averages we're looking at here. And I'm just going to click refresh because this was stats at 10:20 and I want them as of 10:30. And so these averages are all the VDisks on it. And again, we get this latency breakdown of where this is coming from. And if this doesn't refresh right away, I will pop open a new one. I don't want to keep you guys waiting.
We had a question here, Rob.
Question, yes. Okay, so there's a question while I am waiting. What's the network interface on this appliance? 8 gig fiber channel, or is it 10 gig iSCSI? It is none of the above. This is NFS, and it is NFS for a reason. With NFS, you have your demarcation point on the file server is, if it were block-based, which is fiber channel or iSCSI, then it would be up to the host to manage that. And the file system they would use is VMFS for VMware, and they're responsible for all the metadata that manages sharing and lots of hitting at the same time. Now, NFS is cool because the hypervisor knows absolutely nothing about us other than the fact that it is incredibly easy to mount one of these, where we just say new data store, and when we mount our data store, actually this is one of the ones where the vSphere web client's even better, because I can add it to the top node, it'll add it to everything in one shot. I just go in here, I'm gonna select storage on a particular host. Again, vSphere web client will do them all. NFS, hit it, server is just gonna be some kind of IP address of my NFS one. Folder is gonna be /Tintri, and a data store name is gonna be this name. So in this case, EC6090. What do we see here? We see a capacity of it of 91.53 terabytes. That matches this number right here. And it does so because we're getting a 3.3x space savings factor. Okay, I'm gonna stop. The question was simple, is this block or not? It's NFS. I'm going down a rabbit hole. Let me get back to the memory management. There's another question on educational pricing. Wade, shoot me an email after. I can get back to you because I don't know the answer offhand. There's some sales guys on the line that might be able to chime in. Let's see here. We've got our VM view. So here are the VMs that we care about. They're incredibly easy to sort and find. We have lots of fields to choose from. I can right click here and I can see things like performance, space, data protection. These are groupings that we thought made sense. And then we get a whole bunch of these here, including things that have absolutely nothing to do with storage, like percent ready time, which is a personal favorite of mine. This is percent ready time for every single VM. If you've ever used ESX Top to dig this out, this is you know, it's kind of tedious. Here's one shot right now. Do I have any ready time? Ready time would be where VMs are stepping over one another because there's not enough, because your CPU is oversubscribed. That's a very short version of it. These are some anomalies being caused by some of the pressure that I'm putting on these things. These are somewhat impossible numbers, but when you get into the, hey doc, it hurts when I do this, weird things can happen. So let's get back to a particular VM, such as that limit 0 gig. I can see its history over time, so you can see where I spun it up at, it was born at 2:50 a.m., and I spun it up at 3:10 a.m. This is the I/O of it, and this little QoS checkbox will tell us kind of like an apples to apples version, sort of tells us what year it's in. So if it were normalized to 8K block sizes, this would give us an indication. If it's 8K, there won't be any of this purple haze on top. If it's a very large block size, and we'll see this with some of the swapping, this will be massive. The paging in particular in Windows is very large block size to the tune of 224 to 256 kilobytes IOs. So this one, I can see the history of it, and it looks like it's been pretty flat. And to my surprise, that thing is stuck. It's on a screen that says Windows loading, yet there's activity on it. And I can see if it's got any latency. Nope, it's all very low latency. In fact, there's no network or host latency. It's just flash latency at 0.1 milliseconds. And I can look here at things like CPU and memory, and I can see that it is using CPU right now as we speak at 24%. These are 10-minute averages that are coming out here. And on the right, as I click on anything, coming out from the right are 10-second averages. So this is where you can see some real-time stuff. So I can see that this thing is swapping, and it's swapping at 70, 80% of it is swapped. So let me get in a little deeper. So I'll go to virtual disks, and just like every 1,000 VMs on this thing, of the 1,400 vDisks on here, which belong to different VMs, I can see all of them individually. So let me just put on a filter here for name matches any part, lim 0 TB. And we can see limit 1. And I can see quickly that, hey, look, IOPS, these are active IOPS on the box right now. We have IOPS running at 2,500 IOPS. So that means the swap is active. In a perfect world, you wouldn't have any swap at all running. So let's see if we have any in our whole environment. That you could go to every host. You could try and find some swap that way. You can have alerts on swap lots. Here's a nice little trick. If you've got a VMstore, is that we can go in, we can go to our virtual disks for the whole mass of them and just type in swap to get a name match. So now of every swap we have in here, let's sort it. These are the ones that are currently active right now. I can double click on this to see the history of this swap file. Now swap file is going to be created when you power on a VM. So and it's going to be equivalent to the size of memory of that VM. So this particular VM is going to be, let me change here from a performance use view to a space view. This particular one is provisioned at 64 gigs because this is a 64 gig VM. What we can see also is that we have a logical live footprint. So I'm just going to hide these graphs. I just wanted to show you that I can see the historics of just the swap for this particular VM. Hide these graphs and look at all the swap. Now, yes, I cared about the IOPS that were going through it, the performance. So I can go back to performance view or just add something like a normalized IOPS to this right now. And I can sort by that field and see who's hit it. But what I'm more interested in actually is this logical live gig. So what this is telling me is how much of this swap file has been unfinned. So we can see that I have consumed 43 gigs of logical space. I can see the space savings factor. Did you ever know what the compression factor of swap data is? Does it matter to what you're running? Well, it does matter because I've got different instances of different VMs that have unique compression factors for the data that's in it, depending on how squishy it is, and then the overall space savings factor to how much that dedupes to the rest of it, and then how much use space that's taking. So now I can see who's ever swapped. Now, public service announcement, when I power off my VM, my swap is going to be deleted and get recreated when I power it back on. So my provision size is going to change up and down based on my power state. So if this has been on, a reboot will not clear this. So if you're concerned about swap files taking space, even though we can go and browse in the data store here, and we're browsing, and let's take a look, and we can look down here, and it just looks like any of our normal stuff. We can look inside one of these VMs. We can see that in here, we're going to find our swap file. These swaps here are going to look like they're full size at the provision size. In this case, it's 8 gigs. It does not mean it's consuming 8 gigs of your storage. In fact, here's ones that are provisioned out, and they're not consuming anything. So they are thin. Otherwise, it would take a lot of I/O to zero this out at power up. Now, there's an exception here, which are reserves. So if I was getting any of this, so here's a question in related to fixing any problematic stuff. So if you find that you're swapping, then you can either take off the memory pressure on your host by getting rid of some of the VMs on it, or, and again, we can identify that on the host and the VMs themselves. So hosting cluster, if I go into one of them, performance, change to a memory view, we can see in memory real time, if swap is not there, swap used, you can add it from your chart options and throw it in there. And there's a whole bunch of stuff in here. So if you are using swap, you can move some of the VMs off. If it is a particular one that's swapping that you don't want to swap, you can put a memory reservation on it. So if I look at some of the ones that I had a reservation on, which were my, let me go back, reservations. Sorry, back to my VMs templates view. And this is memres. So here are my memres ones. Here are the swap. Now remember, these VMs are all sized at 8 gigs, each one of them. However, when you put a reservation, anything that you reserve is not require swap because you are guaranteeing the physical memory. So an 8 gig VM where I've given it a memory reservation of 8 gigs gives me 0 swap. So 0 size swap file. It is, nothing's been provisioned for it. When I just do 6 gig, the remaining delta we'll still need to swap for. So hey, okay, if we run out of the 6, then we'll use some swap if we need it. But before we swap, we'll use real memory. This is just saying this is how much is guaranteed. And most of the time, as you saw for the other 1,000 VMs, that swap was completely unused. And so if you're wondering how much swap you would ever need, this is where it's kind of handy to see what that logical live size was, because this is how much it's ever used of it. If you were to make sure you had that much more memory, that should handle your peak load. Similarly, we want to do the same thing with a page file. So how do we know if our page file is there? Because our page file is hidden inside our guest. And by default, it's just going to sit inside your C drive. So if it was paging, it would look like your SCSI 00 drive is just getting really busy in crashing storage. So that could be event logs because you're turning on a lot of debugging and monitoring things. It could be a number of other things in there. It could be some kind of antivirus client. Could be you could be mining for crypto coins. Who knows what it might be? But what I like to do is I like to set up my VMs so that all of my templates and everything I clone from are cut the same way. And what I do is I set a very specific SCSI ID to be used for my page file. So I will set a SCSI ID of SCSI 015 because I don't have too many disks that actually go up to 16. You'd need 16 disks to get SCSI 015. And when I do have 16 or more disks, I do not do them serialized on my SCSI 0 adapter. I will spread them over the maximum number of SCSI controllers I can put in, which is 4. I believe it's still 4, and while the max is 16 per, I believe the vSphere-6.7 max has been bumped up significantly, possibly. So instead of 60 vDisks per VM, I believe the new max is somewhere to the tune of 256. Anyway, we've got SCSI 015. So now I've got a 20 gig drive. My template comes out. My Windows has been configured to use that. When I say my Windows has been configured to use it, what I'm referring to is, let me just jump into any one of these, especially one where I set it to page. We'll go into Windows, System, and we'll just jump Advanced. We'll go over to Advanced Settings. And sorry if I'm going quick, but you can watch the replay, and I'm conscious of time here. And this is where we set our virtual memory up. And of all the drives available, the default here is C, System Managed. I'm setting that to no page file. I'm hitting Set. And then normally I would change page to System Managed, and I would set it. But because I'm doing a very specific test on this VM, this one was hard-coded to 16 gigs page. 16 gig page file shows up in the drive that I wanted it to, which is in my page drive. Easy to see, and it looks like it's 16 gigs. If you were to scan this with a hex scanner or something, you'd see that the blocks are 0, and it's really just an index file. Another way to look at that is, hey, is this page file actually taking space, yes or no? Here's my silly VM tricks, VMstore tricks. I'm going to isolate just to see SCSI 015 for all the VMs I have in here. So just like I did with my swap drive, I'm going to do the same thing with SCSI 015. Do I have any VMs paging at this point in time? And if they are, then they've incurred some I/O in the last 10 minutes. And the answer is yes. Which ones? So SQL page 64 gigs is. A little while ago, if I were looking at it, this is why I use Snagit. I would have seen that right in here. I would see that all my swap ones were up in the top ones here, and they were doing a lot more IOPS. But the fill operation that I was doing on them is completed by now. So there's no longer pressure except for the last one, which is page 64. Why? Because I'm, and page 32, but they're a lot lesser. Why? Because I'm filling these up with much larger files, so it's ran longer. So now I can see the existence of paging. Now, how much short was I short by? So this is virtual memories assigned to a VM. So this is above and beyond what you've been given through from vSphere. And vSphere says, hey, I've given you 8 gigs. And then I went in Windows and said, hey, I want more than that, and I'm going to do disk to do it. And I figure it's going to be fine because I have all flash storage behind it. I got some great low latencies on this, and I get some great performance at it as well. So that's what I'm going to do. And what I can see here is logical live, so how much it's ever unthinned. And what was interesting is as the database crossed the threshold of filling up to where I ran out of space, this is where it started to kick in. To show that graphically, here's the VM. I'm going to go into some graphs for it. I'm going to go into some space graph here. And what you're going to see is data filling, data filling, data filling as this HammerTV ran. So the HammerTV that was running, this one is now finished up. It's just sitting at 60. This one is still running, which is on the page 32. But not as much anymore. This one's still running a little bit on the 64. The swap is still running on the 16. The swap is still running on the 32, and the swap is still running on the 64 gig one. I found that the large swap stuff was very bursty and sporadic, and I found that the page stuff was a lot smoother. But what I found was when I hit a very critical threshold of space, of where I ran out of that space. So remember, SQL is putting the database into memory. When we don't have space for it to go in memory anymore, we will start to spilling onto the real disk, and we will also start to swap it out or page it, whatever the case may be. So we will see things like CPU and memory, and this is where we see our CPU going. And what we had was at this point in time, hard to tell by this, but at this point in time, we went from about an 80% on average for these are 10-minute averages. So every metric you see is 10 minutes. So 1, 2, 3, 4, 5, 6, 7, 8, an hour and a half or so in, all of a sudden we bumped up and we were using about 100% CPU. This was a cool finding that I did not expect. So let's take two of our VMs, the 64 gigs, and let's compare those two. So we're going to hit them both, and we're going to look at their space. So they were both getting filled up. Let's just make sure that we get the right view here. 1 second. All right, yeah, so on top is the SQL page, and on top and the bottom is SQL swap. Started them at the same time, and if the amount of data they took up is an indicator of who's winning the race of populating the database, then the winner goes to swap, because at the same time it got to 45 gigs, whereas the one that paged only got to 24 gigs in the same amount of time. Now, looking at why that might be, let's compare our CPU and memory. So what I said was it was running at around 80% memory or so. And this one was also running at around 80% memory. Now, the difference here is that when this one ran out of memory, physical memory, which was almost right away, it started to swap right away. It ran out early because I had set if I wanted to get more apples to apples, I probably should have put my ceiling, my limit at 8 gig to be the same as when the paging is going to start in Windows. But instead what I did was I set it to 1 gig. So after 1 gig was consumed, we started to swap right away. We can see the swap is happening here. We can also see that it looks like the swap just jumped up. Again, this is the flaw of averages. We're going to see it go up and down on the 10-second averages, and those will average out. And I expect to find some average in the neighborhood of this kind of percentage here. And what we can see here is that this one went up and took a little less CPU, or about the same, somewhere in the neighborhood of 77 to 80%. And we move forward and we move forward. And when we go past this junction where this one went to 100%, this one did not. So one of my big takeaways here is that I did not expect that given that the backing disk is identical for both, the priority to get to disk is the same for both, that I would have a CPU penalty. Now, it's not to say that the host hasn't absorbed a CPU penalty, because the CPU we're looking at here is actually VM CPU, not host CPU. So the host can have some CPU overhead to do the swapping, but all in all, looking at the amount of data filled up, the one that swapped was better. So I'm not going to say this as a final conclusion because, again, this is some tests that I ran overnight last night, and I'm kind of reviewing the findings right now with you. These are things that I would run more and more tests at in a much cleaner environment to give a confirmed answer that, yes, I strongly recommend that if you had to choose between paging in a guest or choose between swapping at the vSphere side, swap at the vSphere side. One of them might give you the warm and fuzzy and make it feel a little more visible, but this one's going to give you better performance. We're able to deduce that. So the ones that I'd started up earlier in the beginning of the call here are 3 of them on our limited servers that had a ceiling set to 2 gigs, 4 gigs, and 6 gigs. And this just started to do what I wanted it to. This one is probably in and around the same area. Okay, good. We have a difference. So this is, so what I did here is I went to Performance Monitor. And so again, we have a SQL database here. Refresh. I just created one called TPCC 80. And it is being filled as we speak. I can look at properties of this guy. I can see it spread between 2 disks, my SCSI 1.0 and my SCSI 2.0, which are friendly names going to be E and RF drives. And this thing so far is 2.3 gigs in size. And I can see the other ones are going to be a certain amount in size. Remember, we started them all about the same time. And it should serve that having more physical memory is better and faster than swapping. So I would expect that we would see in this guy the similar thing, but I would expect it to be larger on file size. And let's take a look. Again, we're looking at this for the exact, at the same time. It is larger. It is 3.4 gigs in size. And I suspect the other is also larger. Now, what I've done is I've put a counter in here. If you go to Computer Management, Performance Monitoring Tools, we can add something in here. You may not have seen this view before. It is a chart view, which looks like Computer Management and drill down Performance. And there's a little drop down here that says Report instead of your line or histogram view, and then we add the metrics we want. This will not give us historical, but it's nice to look at in a clean report point in time. This is on my jump box, so I don't have SQL Server here. If I were on here and I said add, what I'll see here are a whole pile of metrics that you can add, including SQL Server specific ones. And there's a lot of them. So what I did was I added ones that I cared about. The database that I cared about, if I should have probably added the database for TPCC 80. This was the other one that I was using for HammerTV, but I did not actually access this. So it's not consuming my memory. The column that you see here has nothing to do with that database header at the top. This is the SQL memory management, how it's all being used. And we can see that 2.5 gigs is being in memory right now. We know that physically we have 2 that's split between the OS and SQL. SQL has been told to use a total of 6, so we're paging on some of it. And we go over to our other one here, and we can look at the same kind of stats. We can see that we've put 3.5 gigs into our memory versus our 2.5 gigs versus our 4.6 gigs in the memory. And looking at what that looks like, just going to clear this filter, go to our vDisks, go to those LIM VMs that we had just started up, take a look at any one of them. This is just the paging, and what I'm expecting to see are some IOPS. Now, you might be looking at this thinking it's kind of ridiculous because it's only 11 IOPS or 22 IOPS. Remember what I said about block size. Check this QoS box. If it were apples to apples, and these were normalized to an 8K block size, these 256K IOs are coming in, and this would be equivalent to somewhere north of 300 IOPS. 300 is not huge, but it is much bigger than this 22 would appear to be on the surface. 22 is more or less idle to me. 300 means, hey, something's happening. That normalized curve will match your throughput curve exactly and will match your bandwidth. So what I can see for this particular page file, here it is. I am paging. I started to at 10:30. I had started this, I kicked it off at 10:18, so it wasn't paging just yet. Eventually did it as it filled memory. I would expect this one went a little longer before it paged, but then went ahead and paged all the same. So where this one paged at that time, this one was a little bit longer, and again, a little bit longer. I can also see that my logical live footprint, that I have more data because I had more spillover that landed here, less and lesser. We're out of time. I hope that this was enjoyable. I'd be happy if this is a format that you like. I'm happy to do more of it. Feel free to reach out. We can do more of this. If you've got ideas, please send them over to me, Twitter, at Rob Girard, or through the feedback forums. I'll hand it back to Annie. I want to thank you very much for your time and patience. Again, it's available on demand. And yes, feedback forums are great. And if VMUG will let me back on, I'd be happy to present a continuation of this with even deeper findings and maybe go the extra mile and build a PowerPoint slide. Thank you very much.
Well, thank you so much, Rob, for taking the time to speak to us today. To find out more about the VMUG WebCast program, you can visit vmug.com/learn. You'll also find the recording of this on there in the next few days. And please make sure to complete the short online evaluation that will pop up as you exit the webcast, and let us know how you thought today's session went. And from all of us here at VMUG, thank you and have a great rest of your day.